Hello everyone, Mr. Hayes here. Today we're going to continue our discussion of section 12.4 on phase changes. Last time we covered phase changes that need energy to happen. Now we're going to talk about phase changes that give energy away. So if we look at our list of phases, the ones we've been dealing with are gas, liquid, and solid. Yesterday we talked about a solid going to a liquid going to a gas, and a solid going to a gas. And all of those required energy to make happen. You have to give the particles energy. Why? Let's take a solid for instance. To get those particles to get out of formation, all particles are moving all the time. To get them to move enough to break out of formation and start to behave like a liquid, you need them to move more, which means you need to give them energy. So what happens when we're going in the opposite direction? Well, if we have some air particles and they're bouncing around all over the place, let's put them in a box just because it makes life easier. And they're bouncing around all over the place. They have a lot of energy. For them to start behaving like a liquid and bounce around less so that they have to stick together in a liquid state, what we need some of that energy to go away. When this happens naturally, it's because it's giving the energy to the environment. So, for instance, the first one we're going to talk about is freezing. We're all familiar with freezing. Now, when something freezes, it has to give away enough of the molecular energy, the particles' movement energy has to give away enough of that energy to become stationary. How does it do that? If you have a relatively warm glass of water and you put it in the freezer, the outside has way less energy than the inside. So it gives that energy away to the outside environment and thus cools down enough in order to behave like a solid, become ice. So the technical definition for freezing is the process of moving from a liquid to a solid. The freezing point is the temperature at which a liquid, and it's different for each liquid of course, becomes a crystalline solid. We avoid the amorphous solids because amorphous solids can have some odd behavior here. So again, as the particles are moving around in a liquid state, and let's visualize it right here, they're held closely together by intermolecular forces, but they're not in a fixed position. As they settle down enough, their bonds will kind of hold them, and they don't have enough energy to move outside of their bond structure. And so they become fixed in position and thus become a solid. So that talks about a solid going to a liquid. We're also going to deal with a liquid going to a gas and a solid going to a gas. All right, so let's move on to condensation. Condensation is the process of a gas or vapor cooling to a point where it is a liquid. So, classic examples, the cold drink on the surface of a table leaves the water impression. It has ice in there. So we have a very cold substance, and outside of the container is water vapor in the air. As the water vapor comes in contact with the cold surface, and it can be made cold by what's inside or what's outside, the water vapor in the air starts to condense into water droplets on the outside of the glass. This is how dew is formed. This is how Water condenses onto your windshield when it's foggy out. Now, this has a large connection to earth science because the condensation of water helps our plant cycles in the form of dew and things like that. The condensation is another way that we can talk about how rain is formed, right? So at high temperatures or at high altitudes, water vapors will condense into droplets and that forms rain. So these processes are a large part of our understanding of how our environment works. So let's go through a couple of these before we talk about deposition. So let's say we have a body of water, maybe a lake. Well, we already talked about as heat from the air, as sunlight hits that lake, we have some evaporation, which is vaporization that occurs on the surface. And it releases water vapor up into the air. Well, as it gets higher, that water vapor can cool down. As it cools down, it will turn into condensation, thus make water droplets. And that's basically the process for the rain cycle. The water cycle is a lot more complicated than just that, but that's a key part of our water cycle. So finally, let's talk about deposition. Deposition is the process of changing from gas to solid. And we experience this in a couple of forms we've talked about before. Frost is a common example of deposition. Snowflakes are actually a form of deposition where the water vapor in the air freezes into a crystalline structure and falls in the form of snowflakes. All right, so of course these have opposites and parallels. So compared to what we talked about yesterday, melting is solid to liquid, whereas freezing is liquid to solid. Vaporization is liquid to gas, whereas condensation is gas to liquid. Sublimation is solid to gas, whereas deposition is gas to solid. All right, next thing we're going to talk about is a phase diagram. So phase diagrams are graphs that indicate pressure and temperature values that dictate states of matter. So here we have the phase diagram for water. Now, before we go into this, I'm going to discuss a triple point. A triple point is the point where the pressure and temperature values allow all three states to exist simultaneously. So let's go over some things here. So on here we have pressure in kPa, kilopascals. So, and down here we have temperature measured in degrees Celsius. Remember, water freezes at 0, boils at 100, typically under standard pressure. So standard pressure in kPa is 101.3. So that's this line right here. So what does this mean? Well, if you meet these conditions, like let's say you have a roughly 200 kPa, so you're right here on the pressure chart, that's double the Earth's atmospheric pressure, and you're at, let's say, 10 degrees Celsius, somewhere around here, you can follow those lines and go, at that particular state, water is going to be a liquid, right? Every element, compound, substance has their own phase diagram. So let's look at a couple things. If you get under 0, water can exist as an ice. Well, I should say this. If you get under 0, commonly water is ice at standard pressure. That's right here. But we can easily switch back and forth. So if we have a pressure set up so that it crosses this barrier, goes from ice to water, when it crosses that barrier at that pressure, that would be melting. If it crosses back, it's freezing. Here, if we cross this barrier here, that's water to vapor, that would be vaporization. But if you cross back, it'd be condensation. And finally, if you can achieve the pressures and temperatures here, you can create deposition and sublimation, depending on which way you're going. So, if we look at this at about 0.01 degrees Celsius, slightly above freezing, and 0.6 kPa, which is a very low amount of pressure, we can get water's triple point, which will behave, as it fluctuates around that, we'll see water as a vapor, a liquid, and solid ice. So a couple things of note. It requires us to lower the pressure. If you notice, if you take liquid water and you lower the pressure, as the pressure goes down, it turns into vapor. Now the same is not true for raising the pressure. Raising the pressure does not turn it into ice. You have to lower the temperature some. I mean, if you're at certain points, like if you're right here and you lower the pressure, you can transition to ice. But what you can do with the substance kind of depends on where it is on this chart. So the last thing I want to talk about is this critical point. The critical point is the point where basically liquid water can't exist anymore. After that point, after the critical point, it's going to be in a vapor state. If your temperature gets high enough, it's just guaranteed to be a vapor. So what I would like you to be able to do is look at this for a while. I'm going to clear out all my drawings. And I want you to think about what would happen at certain points if we raised or lowered the pressure, or raised or lowered the temperature. So the first point I want you to think about is right here. Below 0, what happens if you raise the temperature? What happens if you lower the pressure? If you raise the temperature, the ice will go from a solid to liquid water. If you lower the pressure enough, like way, way low, it'll turn into vapor. That means you can sublimate ice, turn ice directly into a gas. If you did both at the same time, you'd probably pass into a liquid state first and then maybe into a vapor as the pressure dropped. All right, let's start here. So let's think about what happens as we go up in temperature, down in temperature, and down in pressure. So as we go down in temperature, it's eventually going to freeze into a solid water. As it goes up in temperature, it's going to boil or vaporize into a water vapor. But as you lower pressure, it's also going to turn into a water vapor. Finally, what about right here? At 0.01. What happens if you raise temperature, lower temperature, raise pressure? Well, as you lower the temperature, it's going to turn into solid ice. And as you raise the temperature, it's going to continue to be a vapor. But if you raise the pressure, you're going to walk right into the critical point. And so it'll exist at all three states. And if you raise it past that, it'll be a liquid. All right, guys. So that covers all of section 12.4, all of chapter 12. We'll be having a work day tomorrow. I'm going to post a review guide tomorrow morning for you guys to work on. And then we'll have a Zoom session on Thursday to go over any questions you guys have before the quiz on Friday. All right, see you guys then.